This is for number 58 in chapter 3. So reading through everything, I've drawn up what they've given us. So we know that from the field goal post we are 36 feet and the height of the field goal post is 10 feet. We converted those over to meters, which I've written here, and put them into here. So now we just need to find out the angle that it needs to be kicked at. So that's just trigonometry. So you take tangent theta equals to the opposite over adjacent, so 3.048 meters over 10.97 meters. Manipulate this and you get theta equals inverse tangent 3.048 meters over 10.97 meters, and theta equals 15.5 degrees. Alright, so that's for part A. Part B is a lot longer, so I need all the space I can get. So part B, it's asking if the ball is kicked at 45 degrees above the horizontal, what must its initial speed be if it is to clear the bar? Express your answer in meters per second and kilometers per hour. So if we take this, we need to first find what the time is going to be. And there's just going to be a lot of substitution. So in the x direction, we know x minus x0 equals initial velocity in the x plus 1/2 acceleration in the x times t squared. Well, we know the acceleration in the x direction is 0, so we can just get rid of that. So this turns out to be, if we're trying to find, oh, I forgot time right here. If we're trying to find the time, you can just divide this over, so it becomes x minus x0 over initial velocity in the x direction equals t. And we also know that initial velocity in the x is equal to v naught cosine theta. So we can plug this in for that. Now we just do the same thing for y. So we have y minus y0 is equal to v, or velocity in the y direction, times time plus 1/2 acceleration in y times t squared. Now in this case we're going to use a negative velocity for acceleration. So a is going to equal negative g, and then we can just plug in things that we already know. So for time, we're just going to use this with this plugged in for v naught, and you'll see that in a sec. And then also we know that v naught y is equal to v naught sine theta, which we can plug in right there. So once we get all this plugged in, you'll have this equation, y minus y naught equals VO sine theta. So that's what we have here. We just plug this guy in for that. And then for time, we're going to use this over here. So that becomes x minus x naught over v naught cosine theta minus 1/2. So I changed this to a negative. It's positive here just because we're multiplying by a negative g. So I just multiplied it in right there. So 1/2 g times time again, which is this, x minus x naught over v naught cosine theta all squared. Now we just need to move this all around to solve for v naught. And we can combine these because we have sine over cosine, which is equal to tangent. So that's going to turn this into this here. That is tangent theta. Tangent theta minus 1/2 g, and then x minus x naught squared over v naught squared cosine squared theta. So I already multiplied or brought in the square here, so the square goes into there, and then each of these terms here. So now we just need to solve for v naught, and this is just a lot of manipulation at this point. And out of space, so I'm going to start over. I already erase all this. So this is what we left off with. Minus 1/2 g x minus x naught squared over v naught squared cosine squared theta. Alright, so a few things that we can do right now. Let's see, where did I go from here? I multiplied this across, or sorry, I added this whole term across to here. So y minus y naught plus 1/2 g x minus x naught squared v naught squared cosine squared theta equals x minus x naught tangent theta. Now I move this across the y minus y naught, so it becomes 1/2 g x minus x naught squared v naught squared cosine squared theta equals x minus x naught squared tangent theta minus y minus y naught, and then multiply this across, so then we get, if I just multiply this across, we'll have 2 over g. And now since these are on equals, or they're both on a side of equals, I can just flip both sides at the same time, so that we can have this in the numerator instead of the denominator. So we're going to flip that. And this becomes g over 2x minus x naught tangent theta minus y naught. And now we're going to square root both sides so that we can get rid of the square root here. And this, after we square this, we'll lose this square, and this square. And I can just multiply this across and then divide by the cosine theta to leave initial velocity by itself. So I'm just going to do that in one step. So initial velocity equals x minus x naught over cosine theta square root g over 2x minus x naught tangent theta minus y naught. And now you just plug in the terms that you already have. So it'll look like this. And we're again looking at the degree being at 45. And if you plug all this into your calculator, it'll give you V naught, or initial velocity, is 12.2 meters per second.